I just see the data. I can see how everybody's tracking. I can see their progress and they get better. But then I call the clinician. Well, this person, his scores got better a lot. And they said, yes, his mother was overjoyed because he was like a new person. And then you talk to somebody who's got ADHD clients and I see, well, these kids' scores got better. What's the story? They're improving. Their attention got much better after doing brain training. I have to check in with clinicians and say, okay, how did this do? And that's sort of what we do. We help enable them to hand out the Brain Gage and figure out what works for you. You need to see which treatments work, which treatments don't. And by treatment or intervention, it doesn't have to mean you have to take a pill or you have to go get some fancy treatment. Your intervention could be, I don't go outside enough. Maybe I should start walking. And, for some people in some age groups, going out walking 20, 30 minutes a day and line that up with your results, and you can say, oh, that does help.
Welcome to the Rhett Bennis Podcast, where I bring together a variety of experts in the field of helping you live a happier, healthier, and more fulfilling life. With us today is Dr. Mark Tommerdahl, a researcher and professor of neuroscience for over 20 years. He's used his experience to develop Brain Gage, a groundbreaking pocket-sized tool that both measures and improves brain health and performance. His tool is being used to help people dealing with traumatic brain injuries, dementia, autism, ADHD, and numerous other neurological issues. It was a fascinating conversation. Let's go. Let's just jump into it. Why don't you tell us a little bit about Brain Gage and what it is that it does and who it's for?
Yeah. Well, thanks for reaching out, Brett, and tell you a little bit about Brain Gage. Brain Gage is an objective and accurate way to measure brain function. And we do this by probing sensory nerves. And basically, we vibrate fingertips and activate specific places in the brain. And when you activate those places, they talk to each other in a specific way. And the short version of the science is that we basically take many, many measures of connectivity, different types of connectivity, how are cells talking to each other, how fast our pathways engage, what kind of coordination is there between different parts of the brain. And that in a nutshell is what all the different measures that we make or we take when we use the Brain Gage do. To take a standard battery test, it takes 15 to 20 minutes. We also have a quick check that takes 90 seconds. And clinicians are using this as a basic vital sign now. They take the Brain Gage, the quick check is something that's very practical to take a measure every time a patient walks in the door. And that's just part of it. So usually we do in-depth measures at the beginning of a patient consult. We do quick check to track their progress and see how well they're responding to treatments. And then we also give them the opportunity to exercise their brain and improve their brain fitness in the Brain Gage gym. So this is something that's been developed over the past 45 years. I went to University of North Carolina as a grad student in 1980 and went through all my graduate years. I was studying how the brain worked. And then over my postdoc years and early faculty years, we're studying in the lab, using animal labs, studying at very high resolutions you can't achieve in medical imaging. And that resolution is probably 1,000-fold what people can see now with the most modern medical imaging. So we have a lot of insight on what these different sensory stimuli do. And it's, it works really well because we could see what types of places in the brain are activated when you stimulate the fingertips in a certain way. And then we can see what kind of interactions happen. And then it predicts what someone would feel or what their sensory percept would be. So sensory percept is a measurable quantity. And most people, don't know what sensory percept is, but as soon as they do know what sensory percept is, they're just not aware of that knowledge because they've used an eye chart. At some point in their life, they used an eye chart, and that did a very, very good job of figuring out whether they need glasses or what type of glasses they need. So the Brain Gage is a sensory perceptual test, except it vibrates fingertips. And the thing, basically it doesn't come through the images. The testing doesn't come through the visual cortex. It's very simple. It's not language based, and not being language based opens a lot of doors to a lot of populations, young and old. So it's, basically when you're playing games when you're playing games to test brain function or doing questionnaires or doing self-report, that doesn't work too well. And I'll give you an example, or just broad brushstrokes here. Self-report is when a patient walks in and says, my brain's not working right. And I don't feel good. That's not a very objective measure because they can say anything they want. And the problem with the huge problem with self-report is great if you have a broken leg, because you can look down and see that your leg's broken and you say, yeah, I need to get some help. But when your brain is broken, you can't use your broken brain to evaluate your brain. And so that's really the short version of that. Questionnaires are a step more than self-report, but they don't really capture. They still are missing the point. So here's the whole point. If you think about the brain and how is it built? Well, it's built on a foundation of building blocks, just like your house or anything else, any building is. Well, and then on top of that, we have things like language and memory and cognition and executive function. Those are all layers that are on top of those building blocks that depend on those building blocks to act a certain way. So when you feel something goes, those building blocks are what go through and trigger the right pathways. And then you use the cognition and executive function
So building blocks, how, as a completely non-professional, non-initiate into neuroscience, how should I think of the building blocks that you're testing with the sensory reactions?
So for example, you'll say one of the building blocks is called lateral inhibition. That's real simple. And visualize vibrating your two fingers at the same time. And when you do that, you activate two places in the brain that are very close to each other. And if one of them is larger than the other, it will actively push down the other one through a process called lateral inhibition. And we've studied this for years. But, the point is lateral inhibition and something else that people may be more familiar with, which is called plasticity, because people talk about plasticity and it's all about learning and things like that. Well, we can also measure plasticity. Plasticity is a functional building block. And when you combine lateral inhibition and plasticity, those are the main building blocks for memory. And that's sort of how memory gets built, is through that plasticity. And we can measure plasticity directly without having to play number games or say, here's a string of words and repeat them backwards or repeat them back, in 5 minutes. What we do is we say, okay, because even if there's something wrong with memory, you want to still get down into what are the different problems. And, we can look at things like different types of inhibition. So
how does testing someone's reflexes and speed of reflex, like how does that test these different areas that you're talking about?
well, reflexes are part of the sort of a more of an autonomic thing. But if you're talking about reaction time or just how fast can you respond to a stimulus, that is a really good test. And that's our big part of our quick check is how do we see if how fast can somebody process information? Well, that in itself, so our quick check is speed, gives you two measures, if you will. It's speed and focus. And speed tells you how fast somebody is moving or thinking. And focus is something that tells you how well they attend or how well they can pay attention. And those two numbers together are very good at basically tracking a lot of things. Now, what it doesn't do, it's very non-specific. And so like the lateral inhibition and plasticity, and that's that you have, I used to give lectures on that stuff, so I can't go down that rabbit hole. But reaction time, we've known about for many, many decades, almost 2 centuries of reaction time studies in the papers and in the published journals. Anyway, reaction time is sort of a vital sign. It's very nonspecific, but it tells you it's a real good indicator whether things are going badly or going well. And another example, it's really a systems measure. And so another example of a systems measure is blood pressure. Blood pressure is a systems measure. So they take every time you go to the doctor's office, they're going to take your blood pressure and heart rate. Well, that doesn't tell them anything except you're okay for blood pressure and heart rate. But if your blood pressure is really high, there could be many, many reasons that it's high or too high or too low. So that's when you got to start doing a deeper dive. And so we have tools
to look for.
Yeah. But it's a really good thing if your reaction time is right smack in the normative range, you're probably doing pretty well. And but then if it's not, you need to sort of exercise some other pathways, and that gives you a lot more insight into what's going on.
So you were studying the brain through most of your career, and if I remember correctly, was it studying pain science? Was that accurate, or am I misremembering?
Well, yeah. So originally, the lab that I was working in, and became my lab later, but the lab that we were doing animal studies, and we were studying both somatosensory and pain. Particularly, we were studying somatosensory cortical information processing, and so that is where pain is. And so we also, had to learn a little bit about pain. A lot of people don't think about it, but the somatosensory system, the sense of touch, that is where all the pain receptors are. And a lot of the, big part of the pain center is in somatosensory cortex. Now, some people say there's a pain network and that's just one node, and that's, probably true. But, you can actually remove a part of somatosensory cortex to get rid of pain. So that was done long, 50 years ago for a little in surgery for a little bit. Very short history.
Removing a portion of the brain? Is that what you're saying?
Portion of the brain that is mitigated with pain, that is responsible for pain. And you can do that. It's kind of invasive. It's not really a good way to go to right off your start. But, the people that had it done were chronic, incurable pain. But once that was done, they were able to get off opiates. They were able to move on. Interestingly enough, now today, people are targeting that area with ultrasound and trying to just block that one specific place to lose pain. But I'm getting a lot of track. But anyway, so we were studying different types of pain. And when we first started with Brain Gage, we started looking at different populations. One population was autism, another population were all the different types of pain, and we learned how to differentiate acute versus chronic pain. And in autism, we were able to differentiate the way that they process information, the way that their brain works in comparison to a typically developing individual. And so it's very interesting. And, but then that segued, the autism and the pain studies, because there's a lot of pharmaceuticals that are derived from something that's called GABA. It's the largest inhibitory neurotransmitter system that you have in your brain. Well, then we said, well, we're going to study GABA. Let's study recovering alcoholics, because then we can track and see how it gets better. And they actually have heightened plasticity at the end of 12 weeks of sobriety. So that's very interesting. And then we segued into concussion. We did a lot of different things. We started doing concussion measures, and actually started doing that at my alma mater at Davidson College. And that was really fortunate, because once we started getting concussion data, the Office of Naval Research invited us to be part of their BLAST program. And the BLAST program was led by Dr. Tim Bentley. And he basically saw the value of our methods and said, oh, this could be very valuable for a lot of, for being able to attract service members and see how much better, see if they're getting better, or if they're ready to return to duty kind of criterion. So we sort of went, and then at the time, as we were expanding these different things, you'd meet more people, and then other people kind of picked up using our methods, and we expanded a research network. And so now we've got researchers around the world who use our methods and do this kind of testing, and are able to, learn a lot of things about aging and chronic head injuries and, pharmaceutical issues, substance abuse, you name it. Just any neurological disorder is kind of wide open for the Brain Gage.
So what was the Where did the actual device, the idea for the device come from? Was it that you saw a hole and you said, "Hey, I know how to fill that in the way that current treatments were being done," or is it more of, "I have all this data, let's use it somehow and make a difference," like, or was it something else?
Both of those are correct. And then there was something else. So in the late 90s, I contracted my own neurological issues. And I said, okay, I got to figure this out. And here I was sitting in $1 million lab, $1 million facility, but it was all for doing animal research. And so Brain Gage has two probe tips, but I knew that if we, but by using, we had, but each one back then, each vibrating device, each thing that stimulates each finger cost about $30,000 in 1980 dollars. And so we had two of those, and they also weighed 100 pounds. So that was a couple of 100 pounds of stuff to hold to be able to run these studies. But I was sitting there late at night, all alone, trying to figure out, it's like, I got to be able to track and see if this intervention is working. And it was. And so I was able to, stay compliant with my treatment. And basically I never forgot that. But then a couple of years later, we started thinking, man, there's so much information that we have, so much that, in about how the brain works in terms of animal work. And quite frankly, it was not just from our lab. It's paying attention to what other researchers been doing, but it wasn't getting translated. Nobody was making the leap. Nobody was connecting the dots from bench to bedside. And I thought, well, this would be really important. And it's really important to be able to track and see if you're getting better. It gives you it helps your compliance with what you're doing, and it keeps you from cheating. It keeps you from, it gives you some feedback on whether things are getting better.
Should be good both for the doctors getting accurate feedback, but also for the client to get immediate feedback on how they're doing and getting some of the reward for being able to track themselves and
Exactly.
trying to get in better, improve,
Exactly.
that sort of thing.
Yeah. Some of the clinics that we work with, they do things like people go in and they do what's called a hyperbaric dive. They just go into a little tent and for 45 minutes, and they test themselves, and they test the people before they go in for their hyperbaric dive. They test when they come out after, and people are really enthusiastic about coming back when they see their scores improve significantly after a 40 nap.
And you're referring to hyperbaric oxygen treatment, correct?
Hyperbaric oxygen treatment chambers, and there's quite a few out there, but we're working with people that use those, and they're very excited. And so then that hyperbaric chamber, that hyperbaric dive, this is just an example of many treatments. Many treatments have this property, but they have a period of what's called hyperplasticity. So, that's a time when you are best served to actually do some kind of exercise or use the Brain Gage gym and work on connectivity. And those exercises are really straightforward. It's just like going to the gym. It's just you have different exercises and different levels. We have therapeutic levels, standard level, which most people do. But then we also have a professional level, elite level, which a lot of people are starting to use now because like the elite athletes are using us. They want to be the best of the best, and they want an edge, and they don't like other people knowing about it, but too bad.
And so let's rewind a little bit and just go back into, so the actual device you are able to plug into your computer. It looks somewhat like a mouse because it's worked with your hand, and it has two different prongs that are coming up. And you have software that you use that basically has different games at different levels that test different types of different things, whether it's your reaction speed or whether it sounds like also your memory or different types of things. And there are different tiers of difficulty that you use depending on where someone's at on their journey.
Yes. Basically it's a mouse. It's a mouse sized device. Some people call it a mouse. But I used to tell my undergrad students if they called it a mouse, they'd fail the course. So they never did. But it's because it's a Brain Gage. But really, the Brain Gage is a system. It's a whole system of, it requires a Brain Gage, but it's also 4 million lines of code. And that includes, the Brain Gage gym has different exercises. Just like when you walk into a gym, you have, say, exercise bike, weight bench, pull-up bar. You have different exercises. But you also you get to pick which level of ability that you're going to work at. let's just say, 1 would be the easiest, 5 would be the hardest. And let's say you can only do a 3. You work out at 3 and for 2 or 3 weeks, work at your level. And then you move forward as you can progress. Just like when you go in the weight bench and you say, okay, I want to lift 100 pounds, but I can only lift 60. Then you train at 60. You do what you can. The testing is different because it's a little more scientifically rigorous. The gym is very relaxed and it's very easy to follow. The testing is rigorous in that it starts out, and it's much more like a eye chart where it starts out easy. And as you get as you answer correctly, it gets harder and harder as you go along. Just like reading that eye chart, you get down to that bottom line and you either guess or you just give up.
So it responds to you live as you're doing it.
Well, each time you answer correctly, it gets harder. So that's the gist of it. It's called a tracking protocol, and it's really simple. Yeah, the underlying stuff is a little more complex than that, but that's good enough. Because otherwise, some people there's 2 or 3 lectures of different tracking protocols, but we won't go into that. So that's trying to learn how to cut things short.
So what type of person, you've mentioned several different people who would possibly benefit from this, whether it be autism, whether it be people who are getting older, people who are having developmental issues. What type of person would be ideal to jump in and start using this? Or is it everyone who has issues with their brain?
Okay. So there's a couple of different options too, like which path do we go down? So let's go by different groupings. So the first group, let's say, is aging. Aging is that's really anybody over the age of 50 or 60, depending on who you are. If you want to just track your brain health, if you want to improve your brain health or maintain your brain health, the Brain Gage is a good way to the Brain Gage home unit. You don't have to go to a clinician to get one. You can come straight to us and get a Brain Gage home unit. Well, and then once you do that, you start to see things like, oh, I tested, like some people test and then they drink a couple of espressos and they test again. They go, oh, okay, I'm walking out the door and I feel much better. And so they realize that their brain is working the brain is optimized in certain states. And then they realize, I get calls all the time from people saying, oh, I found out that my test scores were a lot worse when I drank a lot the night before. And I just say, that is true. And so actually I've talked to people who are much more compliant or you just start realizing, the older you get, you do not have the capacity to just keep playing so hard. And then they also find out when they're in shape, their Brain Gage scores are better. Okay. So that's just the very small part of it. In the in the clinic world, it's really anybody any care provider that wants to help their patients with their brain health. For all the reasons we just mentioned about compliance, the patients are more compliant when they come in and they know they're going to get tested. And they also are much more enthusiastic when they're walking out. A lot of the wellness clinics we work with are doing this, and they work with people from early age all the way to 90s and however long. So, and basically these people they're coming in and they're doing a number of treatments, whether it's hyperbarics or ozone or pulse electromagnetic field or microcurrent neurofeedback. It doesn't matter what the treatment is. If the treatment is targeting brain function, then it's helpful. Sometimes treatments are not targeting brain function, though. Things like chemotherapy for cancer patients. Well, chemotherapy is well known to decrease cognition, but this gives you a way to help find out what helps you maintain that cognition. And, all this is going on in a lot of different clinics where people are tracked. At the young stage, what we're seeing a lot of is people are using this with adolescents who have ADHD and having them do brain training to improve their focus. And that's really impressive. It's also complements the treatments to do the brain training along with those treatments. As I mentioned, there's this period of hyperplasticity. But rather than thinking about hyperplasticity, sometimes when there's things that go wrong with the brain, what you want to think about is their brain is people get brain cramps, okay, in different ways, and they manifest in different forms. And there's different treatments that have been found to be very effective with this, and broad categories called electroceuticals. And that's pulse electromagnetic field, microcurrent neurofeedback, et cetera. And so after, somebody's treated with that, then basically what they've done is it's sort of the physical analog of this is that a little bit like getting a massage before you work out. There are massages for recovery and there are massages that people get before they work out. And sometimes that will help people, especially if it requires flexibility. So there's all these things that line up. And, what does your brain need? Flexibility and physical flexibility. The mental analog is plasticity.
We'll get back to that conversation in just a minute, but I have a quick question for you. You know anyone who's working to improve other people's lives who perhaps aren't getting the credit or the recognition that they deserve? Reach out to me and I would love to feature them on this podcast. Thanks. If you've been enjoying this podcast, you might be interested in some other resources we've been developing. Search benniscompanies.com and you will find books, podcasts, and other resources that we're developing to help you live a happier, healthier, and more fulfilling life. Back to it.
So that gets them much more malleable and ready to do training. And when they do training, it really helps them even more. So we mentioned developmental disorders. Well, not quite. ADHD is considered a developmental disorder. So is autism. We've had a few case studies where brain training looks like it really had a big impact on the individual. Concussion and people that are tracking recovery. Now, the interesting thing about this is that if somebody's doing brain training, it improves their cognitive reserve. Improving your cognitive reserve is a little bit like, let's go back to the physical analog. That's improving. If I say you need to go lift weights to improve and work out to improve your physical reserve. Well, that means if you're physically fit, if you're not an 80-year-old, 80-pound person who's very frail and about to break a hip, well, what you do with that person is just like, let's put a little weight on, let's get you work out, put on 10, 15, 20 pounds, and all of a sudden you're not worried about them breaking a hip anymore. Cognitive reserve is the same thing. Turns out if you have increased cognitive reserve, you'll recover from injuries faster. And also if you're doing like exercises with the Brain Gage, you can recover faster as well. So it's kind of, okay, that's the concussion and TBI category. It helps apparently. I mean, we haven't really looked at anybody with say PTSD and anxiety with just the Brain Gage. We've done the Brain Gage as a complement to the other treatments, but it does seem to give a boost to people under those conditions when they're coming in and they get their different types of treatments for those issues. And then they do the brain training afterwards. And then another feature of this is that a lot of patients will take Brain Gages home and the clinician can see their results and see if they're training. So that's why it's kind of a whole system. Basically, seeing this.
I could also imagine it being a good way to establish a baseline before going into any kind of either surgery or treatment or anything like that to understand this is where I was and whether or not it's just the treatment is geared to improve brain function, or if you mentioned chemo, if you go through and you have reduced brain function, it gives you an idea of this is where I was, this is where I am, and let's work back to that point.
Right.
I could see it both pre and post, all sorts of things.
Yeah, even ketamine anesthesia, ketamine is pretty common anesthetic, but if you're knocked out for something as simple as a tonsillectomy, it's going to take you 2 or 3 days to get your brain back on track. I mean, that's if you want to track that and see when you're back and ready to go again, then that is also helpful. Or if you see, well, it's not getting better, maybe you better take some positive and some other kinds of actions to help catalyze that progress.
Kind of outside the health and wellness sphere, but I could imagine this even being eventually integrated into, for example, entry exams for a job or a position that would require high plasticity or high brain function. I could imagine that being something that's implemented.
Yeah, I did talk to somebody about this. It must have been 8 or 10 years ago, and they were thinking about that, and then they thought, I guess it was the issue. Then becomes it's a whole nother layer of litigation that they were worried about in terms of, well, if this shows that they're not good enough, then it's a wild hair. But speaking of litigation, we have testified once or twice. People have used Brain Gage in a couple of court cases, but that's I can't talk about them. You're behind closed doors.
Okay. So if someone is just watching this video or listening to this podcast and going about their life, what might be an indication that they should look into this? What might they be experiencing in their everyday lives if they're not in one of those categories where they have a known disorder, or they know that they're getting older, or what might clue them in?
Yeah. Well, here's the thing. A lot of people expect to have their brain health get worse as they get old. But, as there's a many thing, we have multiple measures, as I mentioned. Several of our measures do not change with healthy aging. But there is one measure that some people swear makes you worse, that gets worse with aging. I mean, this has been published many, many times, and they say, oh, your reaction time gets worse as you get older. Well, that's really because there were a lot of sloppy studies done. The way to think about it is, as we age, the number of people that are aging in the healthy category gets smaller and smaller. So if you take somebody at age 20 and they can have all kinds of bad habits, they're not going to be that different from the star athlete who works out all the time and studies really hard. I mean, there's a small difference, but it's not that big. But then if
It
you
hasn't set in yet.
you jump up to age 60, the difference between sedentary and active is enormous. And, it's just that the percent of population gets smaller and smaller as we get older. So by the time we get older, either you've had multiple head injuries, you had a bunch of concussions playing sports, or, you had a substance abuse problem. And even though you got rid of it, you still need to keep doing things to get your brain back in shape, or, you had chronic pain. So all those things add up, 20 or 30, I think this numbers are like staggering. About 30% of the people out there at some point had some kind of chronic pain or pain issue. So it's really a large number of people, and all those things contribute to degenerative processes. But I can give you an example of somebody who was doing a 78-year-old gentleman who was at the early stage of dementia, memory loss. And so his reaction time, and so keep in mind, I'm going to throw out numbers. Normal reaction time, this is how fast you respond. So I want you to think, okay, you're an Olympic swimmer on the starting box and you hear the gun go off and boom, you want to go as fast as you can. You want to hit the water right away. That's what your reaction time is. Well, and so that normative reaction time is in the 200 millisecond range. Well, this one particular patient, his reaction time was about 600 milliseconds when he started. And the only thing he did was hyperbaric dives and brain training afterwards. And in 2.5 months, he's now at 170. So that's really impressive. He's better than average.
Is this a geriatric client?
This is at a wellness clinic. No,
Okay.
regular wellness clinic, walked in the door, and apparently, he had trouble making conversations early stage. Now he's back. So don't just say, yeah, I'm getting slower, I don't need to do anything about it. Guess what? You can do something about it. You can exercise your brain. And a lot of people say, oh, I do puzzles and I do this, and I play games on video. I play these video games. And I'm sorry, but there's a million scientific reasons that doesn't work. And there's also data that shows it doesn't work. But if you use something that's physical, like the Brain Gage is actually a physical device that you have that engages your sensory and your motor components at that level, a very highly accurate and optimal level, then you've got something that works. And I've been pleasantly surprised to see how people have gotten better. I mean, I can give you a couple of examples. People only use the Brain Gage to recover from a couple of things. Like one was dyslexia, and the person, had really bad dyslexia in their late 30s. And then the treatment they were given was the Brain Gage gym. And 7 months later, they had perfect scores across the board. And then another case of somebody with memory loss. They were tracking themselves on the Brain Gage, and the treatments weren't getting any better, and their memory loss was still there after they started training. their scores, all of a sudden they got better and their memory loss went away. So those are just cases.
Memory loss too.
And that
It
person,
affect memory loss.
that person was much younger. And of course, it scares people when you start. I mean, everybody gets, you forget names every once in a while, but as you get older, you start worrying about forgetting somebody's name or forgetting the name that you want or the word that you want to recall. But there's different ways to exercise it. And we have there's an accurate way to measure your progress, even if you don't use the brain training and all you do is track it to say, hey, you know, I'm gonna go to work today, but I'm cleaning black mold out of this guy's house. Let's see how that impacts me. It'll probably impact you a lot if you don't wear proper upper gear. Anything that I guess anybody that would want to track their brain health, anybody that would improve their brain health, that's check on what their brain fitness is a candidate user.
So, can you talk a little bit about some of the results that you saw? You mentioned the autism and the ADHD and all that. Can you talk a little bit more about those case studies and what it is you saw after using Brain Gage with and without other treatments?
Okay, so keep in mind what I see. I just see the data. I can see how everybody's tracking. I can see their progress and they get better. But then I got to call the clinician, and then we talk about. I say, "Oh, well, this person, his scores got better a lot," and they said, "Yes, his mother was overjoyed because he was like a new person." Okay, so that's compatible. And then you talk to somebody who's got ADHD clients, and I see, well, these kids' scores got better. What's the story? They're improving. Their attention got much better after doing brain training. They have to keep doing it to stay on target, but it's helped a lot. So I don't, I have to check in with clinicians and say, okay, how did this do? And that's called writing, so we write up case studies. And that's sort of what we do is help people write those case studies, or we help enable them to hand out the Brain Gauge and figure out what works for you. The main tenet to keep in mind is everybody is different. So you need to see what everybody's initial conditions are. You need to see which treatments work, which treatments don't. And by treatment or intervention, it doesn't have to mean you have to take a pill or you have to go get some fancy treatment. Your intervention could be, I don't go outside enough. Maybe I should start walking. And, for some people in some age groups, going out walking 20, 30 minutes a day, get in 8 or 10,000 steps or however you do it, and then see what and line that up with your results. And you can say, oh, that does help. So that's another thing that we looked at. So
I could see for the diagnostic side of things, this could virtually be integrated everywhere in wellness because the brain is so integral to everything that we do. But also for the brain training, how soon after initiating brain training do you start to see results typically?
that's a great question. We'll go back to our physical analog. And it's, basically the brain's made out of cells, just like the rest of your body. And I was a competitive swimmer, and we used to say, you always take time off, week, 2 weeks, whatever, 3 weeks. But then after you take time off, the adage was always 3 days, 3 weeks, 3 months. And that's sort of like 3 days to kind of get your groove on, sort of make progress. 3 weeks to see an improvement in strength, but no increase in muscle mass. 3 months to see really significant improvement. We see similar things with the Brain Gauge. And by the way, I can't take credit for the 3 days, 3 weeks, months. That was a guy named DeVries back in the 1970s who studied exercise physiology or muscle physiology or both. But he was looking at, how do we progress and when is muscle mass made and things like that. It pays to look back at literature like that. But it really does parallel that. And so our gym is designed because there's so many physical analogs to brain improvement. The Brain Gauge gym is designed to be like a regular physical gym where you have different exercises, and it will take you, in 3 days, you'll get a little bit of improvement just because maybe you read the instructions wrong, but you'll see real improvement in 3 weeks and then really significant improvement in another 3 months. That's actually what the person with dyslexia, we saw, 3 weeks. Yeah. All of a sudden she saw huge results. And then after 3 months, it was like, oh, this is really good. so it's no transpositioning all of a sudden. That's a good thing.
And what about with TBIs? I know you mentioned that earlier. What type of response are you seeing to TBIs? I personally have seen people in my life who either come from the military or been in accidents, and you're dealing with PTSD, you're dealing usually with TBIs, you're dealing with multiple different issues. And I would just see this being incredibly important for their recovery. What are you seeing there?
Yeah, like I said, I mean, we were picked up by Office of Naval Research for their blast program, and so obviously the whole point from their perspective was, we need to be able to track service members and actually see how much they're impacted, when are they, and when do have they fully recovered, and when do we do return to duty. So, implementing this in that bureaucracy is very slow. If you think some things are slow, that bureaucracy is really slow. But we did some studies, and we had really good accuracy in a study that we did. One study that we did at a military base, and we're at another military base actually looking at not concussion, but what's the effect of a sub-threshold concussion? In other words, when people handle heavy artillery, it impacts them and impacts their brain. And but it's just a little dip in their scores, and they'll recover in 72 hours unless they keep doing it. If you keep doing it within that 72-hour range, then it's going to add up. It's going to be additive. And then you'll start getting concussion-like symptoms from a sub-threshold blast exposure. So a
And
bunch of many.
that's a really important part because a lot of current diagnostics, as I understand it, a lot of ways that a doctors approach this, they have a certain standard, and if you don't reach that standard, well, you just
Right.
go live your life.
Right.
But there's a whole range of damage that could happen up to that standard, and especially like you're saying, sustained over a long amount of time, that damage can become permanent. And it sounds like what I'm getting a sense of hope out of just hearing about this tool is that it could essentially accurately bring that standard lower so that people are getting treatment sooner than it becomes
We're standing
really
down.
bad.
Or so if you're talking about sports concussion, somebody gets banged and their scores go down a little bit. You say, okay, well, let's just sit out a day or two. If you get hit again, you're going to be sitting out. If you get hit again the next day, you're going to be sitting out for, I don't know, forever. So, we've actually seen that happen. The Brain Gage is a very successful research tool, hands down. We've had a lot of success in research in a lot of different areas. But we converted it to something user friendly so that people would use it. And so the very first version of the Brain Gauge that was monitoring concussion, they get numbers, they didn't know what they mean. So every single concussion, I would talk to the people doing it. And the person would say, oh, this person, look at this person's scores. And I looked at the score and they said, you know what? This person, she passed impact. She says she's clear to go. She wants to play. And I looked, and this was the very first data set we had for concussion. But I looked at the data and I said, yeah, she ain't right. Yeah, I wouldn't let her play again, but I'm not the gatekeeper. That was a long time ago. I said, and they didn't really know. It was a research project. And they said, well, she insists she's ready to play. And again, she scored perfect. She had a perfect score on the impact. Impact is an online cognitive test that is commonly used in colleges and some pro teams and whatever and it's sort of questionnaires and relies a lot on, questions. But anyway, this person, so she went back to play. The next day she got banged in the head. And then she admitted that she had cheated on impact. So on the impact test, and that she did have symptoms. But the only thing that stood out was, he had shown that she shouldn't have been playing. So after that, they trusted our measures much more, and they're very, I still get calls every once in a while, say, can you take a look at this? Because there's ways to go behind the wizard's curtain and take a look. And sure enough, yeah, he wasn't quite ready, and so they delayed him another day, and then he was fine. But in testing, it was just like some of the tests are really, when you're trying to track and see when somebody's ready to play again, return to play or return to duty, it's tricky. I mean, the question is, when can they get hit in the head again? That's never a good question. You never want to get banged in the head, but you just say, when is it safe to sustain even a modest injury? Because sometimes it's multiple modest injuries that can add up. And so you want to track and just see how you're doing. And a lot of times in the heat of a game, I bet a lot of people, they don't notice, they don't notice whether they're hurt or not.
So you mentioned being able to test someone, and you mentioned being able that there's certain reaction times that are healthy. Do you need a baseline in order to tell whether someone has sustained a bad injury, or do you have enough data to just say this person is operating far below what they should be if they were a typical person? Like, do you need the baseline, or are you able to say that without the baseline?
We did all our studies without baselines, all our concussion MTB studies without baselines, except we did go back and start doing baseline testing to prove we didn't need to do it. And we didn't need to do it because we do have so much data, so much normative data. We got 40,000 subjects now in our database, and it's growing every day. But we don't.
So how does that tie in with, you mentioned everyone's difference and everyone has a different, I assume that means everyone has a different baseline score.
So I was thinking in terms of every patient is different. When somebody walks in the door, they don't just say, I feel great, I'm going to go to the doctor. No, they usually, they wouldn't go. They only go when there's a problem. So when they don't have a problem, when they have a problem, it's good to know what is their starting point. Because some of those starting points for treatment, we've seen people have starting points where they could barely function. And then they've gotten and progressed really, really well to where, this is the different interventions people we work with are using are fantastic. And they're doing these treatments and taking people with stroke and people with head injuries. I guess stroke is a head injury, but, and then you just want to see where they are. Because if what you do is normally you take them and you say, oh, they're way below normal. Okay. But then the next time they're not quite as far below normal. And then, it might take 3 weeks for them to start seeing that normative range or the bottom end of, not even the bottom end of the normative range, just back on the scale. I mean, they're way off scale. So that's why you have to get a starting point, just so they can be encouraged that, look, you're getting better each week. Pretty soon you'll be at normative values.
The reason why I ask about the baseline is that I could see how this could become controversial to begin with, but very useful for either sports teams or people who work in military, for example, to have a baseline going in so that they can see how much this has impacted their life and make a decision whether they want to continue going. Are you saying that you don't really need that baseline in order to show that evidence?
Okay, there's a couple of things going on. There's many things going on with baselines. Number one, some like the reaction time measure, it's helpful if you have a baseline, just to know if they are part of that 1 or 2% of people that are super testers, and they're so far above the normative range, they'll get a concussion and they'll be just a little bit above it. They'll still be above it. Now, there's a lot of things about baselines, and baselines are it's what keeps all these cognition or online cognitive testing questionnaires in business. So they go to a school and say, like, one of our goals is make this low cost. And you can thank Office of Naval Research for that, because they paid for the miniaturization, productization, and, where we had to pay for all the manufacturing. So we wanted a low cost method. But keep in mind, let's say somebody comes, says, yeah, we're going to baseline all your kids. This is not us. We don't charge as much. We don't charge any. It's unlimited testing. But people come in, they bring in, say, middle-sized school or small college. They bring in 400 student athletes, and they have them all baseline their freshman year. Okay, so that's $15 a pop. $15 per test for their baselines, and insurance does not cover baselines. Then if one of them gets injured that year, they'll compare to the baseline that was taken. And they'll say, okay, compared to that baseline, and insurance will pay for the non-baseline test. So they save $15. So anyway, they'll compare that person to their baseline and say, oh, you're above your baseline. This is just one of the issues. Now, here's another, the real issue here on issue number one is that they only test people their first year. What about their senior year? They got their baseline their freshman year. Can you imagine anything that some 18 to 22-year-old would do to change his brain health profile over 4 years? In other words, that baseline's no good. Baselines are great. If you really want microscopic resolution, then the baseline with our measures, it'll tell you a lot. It'll tell you how much coffee, show you the effect of your coffee, show you effect of, not enough sleep. But we trying to decide which direction to go here. There's many directions to go. But here's the issue with, let's take reaction time. It's a great measure for the simple purpose. Everyone understands it. The way you do reaction time, we stimulate one finger, respond with another. Now, reaction time with the tactile system or sense of touch, it's much, much more high fidelity than any of the other systems. Visual, when they come in with the online questionnaire, they'll do a reaction time test, and that's what they want a baseline to. Well, let's say you got a room full of computers, or they're doing these tests on different computers. You could and what we did was we tested all these different systems robotically to take all variability out of it. So the Brain Gage has 1/3 of a millisecond variability using robotic input and output. So if you use a robot to do the reaction time test, it will respond exactly when it's supposed to. It'll measure it and respond. It has 1/3 of a millisecond inaccuracy. Okay. Your normal reaction time is 200. Your normal reaction time variability, which is really your measure of attention or focus, is 5 to 15. So just remember 5 to 15. All right. Now, if you go and use an online cognitive test and you do it on a phone, you add 400 milliseconds. So it'll tell you your reaction time will be 600 instead of 200. But if you go and you do it on the same phone again, and again, like we did with a robotics to see what the error was, the error is in the 100 millisecond range or higher. So you can't get the same test. You can't get any accuracy that you need. So their baselines are really no good because they'll get up from one computer and go to another computer and get totally different results. So that's why we call the Brain Gage a lab in a mouse. We moved all the stuff, all the circuitries in there. So we bypass all the errors that computers introduce. And so if you're trying to measure something, say reaction time is a great measure. Reaction time, really good. Reaction time variability, it's even better. It is the most important or the single most accurate objective measure of attention you can get, 90 seconds. There's hands down, you can't get a better measure of attention in 90 seconds. And reaction time variability is taken from the reaction time test. So if you take the reaction time test, all your measures for every single trial were identical, then your reaction time variability is 0. Now, in 40,000 subjects, we've seen 3 zeros. So that's really, really incredible. But most people are 5 to 15. And if you add 100 millisecond error with one of these other systems, you can't do it. So, okay.
I can imagine that making a really huge difference to be able to standardize that. So let's imagine someone is watching this for the first time, learning about Brain Gage for the first time. What is the main thing that you want that person to come away from this video, this podcast with understanding about Brain Gage?
Okay. You want this from paragraph 1? The Brain Gage is a lab in a mouse that basically can enable you to track your brain health, to help you figure out what helps your brain health on your own, to make you your own little researcher. It's extremely easy to use. And it also can give you a Brain Gage gym to work out and see what it's like to work out different aspects of your brain function. And, if that's something that's of interest or of, seeing what things impact your brain health is of interest, and that's something, then it's for you.
Thank you. Where can someone go to learn more about this? Where can they find your product? Where can they learn more about what you're doing?
Well, the best way to find out more about our product is to type in on a search Brain Gage, But here's the warning. The most common misspelling is Brian Gage. So if you type in Brain Gauge or Brian Gage, then you probably won't find us very easily. But Brain Gage, Gauge. And the company name is Cortical Metrics. So you come up to the Cortical Metrics page. We are a research company. The Brain Gauge is our flagship product. And we have many types of brain gauges, but we only talked about the ones here. We do a lot of different things for researchers. Like we put them inside MRIs, and that has to be a special brain gauge. So anyway, that's number one. And on the website, it'll say, schedule a consult. That's me. You just type into my scheduling my calendar, and consults are free. And if you want to learn about more, you can talk to me. If you don't want to talk to me, that's fine too. We have a Brain Gauge YouTube channel. So that has introductory videos. And if you're a real nerd like me, you can go dive deep into the science. And there's a bunch of years of videos on there. And there's like every single measure has its own video because there's a lot of depth to each of these measures. Each of the individual measures we wrote papers on. And we wrote papers, and other people wrote papers, and students of students wrote papers. So there's a lot of other people around the world writing papers on this stuff. And I haven't really kept up with what's going on with everyone right now, but I'm catching up with people right now. So anyway,
I see you have a lot of how-to videos, a lot of introductory videos, tutorials, and ways to learn more on your website and on the YouTube channel. And we'll link all of that in the description. But Mark, I think this is going to be an amazing product. I think it's already doing really cool things, and I'm excited to learn that this is in the market today. So thank you so much for your time coming on here.
Thank you for having me.